All right, boys and girls, the next one that we're doing is example 8, and it's using trig to solve a right triangle. This should look very familiar because you've done it in integrated 2, so it's kind of been a while. But this is when you were first introduced to the trig ratio, sine, cosine, tangent, through SOHCAHTOA. Okay, so here we go. Let me read you the example that's in the book. It is not the checkpoint, and it's not the actual example, okay? But let me read it to you. A biologist wants to know the width, which is W, of a river in order to properly set instruments for studying the pollutants in the water. From point A, the biologist walks downstream to 70 feet and sights to point C. Okay. From this sighting, it is determined that theta is 54 degrees. How wide is the river? Okay. So my illustration just basically shows the triangle. In my book, it's a little bit different illustration. It has the river and whatnot, but this is basically all you need. Okay. So the first thing I would do is label your sides according to what's given. You're given an angle, and if you use this angle as your reference, then this would be your opposite side, and this would be your adjacent side. Okay, why don't I put ADJ just to not confuse that A with that A, and OPP. Okay, so we're given the opposite side. Well, actually, we have to figure out the opposite side, and we're given the adjacent. So out of the 3 trig ratios, which one uses opposite and adjacent? And that would be tangent. So your setup would look like this. Tangent of theta equals opposite over adjacent. Okay, or TOA, or in this case, tangent of 54 degrees equals W over 70. Okay, and all we have to do is solve for W. So we have to isolate W. So first things first, I always kind of teach it. I think it's easier if you teach it by proportion. So I put a 1 underneath here, and I would just multiply these and these. So technically in my calculator, all I would put is tangent of 54 degrees times 70, and that'll give me W. Okay, and I would use the calculator for this. Okay, so now in your calculator, we are working with degrees. It's 54, so make sure you change your calculator from radians to degree if it's not already. So tangent of 54 times 70, and that should be approximately 96. Okay, if you want to keep a couple decimals, feel free. But again, if they don't specify, then I just kind of leave it out, whatever I want. Okay, so they wanted to find W. So W is an approximation, 96, and my unit of measurements would be feet. Okay, and then that's it. And again, this should look familiar because you've done it in integrated 2. Again, it's just been a while, but you've done it. Okay, all right, now I'm going to move on to actually example 9. Okay, so example 9 is basically the same thing, using trig to solve a right triangle. That's why I kind of kept it in the same video. And I was drawing this one, I realized that I'm calling this one extra, and I think in the previous one I put checkpoint, but you're going to realize that it's not the checkpoint. Okay, it was just an extra example. All right, so here's my picture, but let me actually read you the instructions. Okay, a 12-meter flagpole, so this is the flagpole, casts a shadow, a 12-meter shadow, so this is a shadow, as shown in the figure. Find theta, which is the angle of elevation to the sun. Okay, so this time, here's the different. They're giving you the opposite side to the angle. They're giving you the adjacent, so obviously we're still going to use tangent. But here's where it's different. Instead of us finding a side, we're going to find the angle. Okay, so I'm still going to set it up the same. So tangent of theta equals 12 over 12. And then, boys and girls, 12 over 12 is just 1. And then tangent of theta. Now, this one's super easy, so you can use so many things by now because you've learned a lot of things. You can use your unit circle if you wanted to right now. But I'm going to pretend I don't have a unit circle, and I'm going to go back to like integrated 2. Okay, so whenever I want to find an angle, and then this is where we use the blue trig functions right above our sine, cosine, and tangent, our inverses, sine inverse, cosine inverse, and tangent inverse. Okay, and we only use those to find angles. So again, I'm going to pretend we don't know this one because it's super easy by now. You can draw another triangle if you wanted to. You could use unit circle, but this is what it would look like. Theta and then tangent inverse of 1. Okay. And we are going to leave it in degrees because remember our angle should be in degrees since we're solving a right angle. Okay, so we're going to put second and tangent and then just put 1. Many of you probably already know the answer. 45 degrees. Okay, so tangent should be 45 degrees. So my angle of elevation should be 45 degrees. Okay. Awesome. Okay, so I showed you how to find a side. I showed you how to find an angle. All right, now we're going to move on to the next example because it's still similar to these. All right, boys and girls, in example 10, we're solving a right triangle. So whenever they ask you to solve a right triangle, you're going to look for all 3 sides and all 3 angles. Well, depending on what they give you, okay? So let me read you this example. Okay, so it says, a ramp 17.5 feet in length rises to a loading platform that is 3.5 feet off the ground. Okay, find the angle that the ramp makes with the ground. So in this case, it's actually similar to the previous one that you did. They just want us to find the angle. Okay, so let's look at what's given. We're given the opposite side and the hypotenuse. So this is, oh, force of habit. Sorry, I apologize. You're always going to see me make mistakes, guys, and I apologize. Just me rushing through it sometimes. So don't do what I do, okay? All right, opposite and hypotenuse. And that's going to be sine because that's so, okay? So here we go. It's going to be sine of theta equals 3.5 feet. So I'm just going to write it as 3.5, okay? And then 17.5 feet, so I'm just going to write it as 17.5, okay? And then we're looking for theta. So in this case, I would just write theta equals sine inverse of 3.5 over 17.5. Okay. And now let's do that in our calculator. So here we go. Sine inverse and 3.5 divided by 17.5. And that gives us approximately 11.5369. But if I had to round, because we're looking for an angle, which is in degrees, I would say I'm going to round up, and this is approximately 12 degrees, okay? It's too high to be just 11, so I would say approximately. So theta is about 12 degrees, okay? All right, I'm actually going to do another one with you because the next example is a little bit different, okay? So let's move on to the next one. All right, boys and girls, so I'm actually going to do the checkpoint in example 10. So I think that's a really good example. So this is what it says. Find the length C of the following ramp shown in the figure below, and then find the horizontal length A of the ramp. So this one, to solve this triangle, they want us to find 2 different sides, okay? So here we go. We're given the angle of elevation, which is 11.5. We're given this side, which is 3.5 feet. So all I need to find is these 2. So according to this is the opposite side, this is the adjacent, and this is the hypotenuse. Okay, so basically, why don't we solve for C first, and then we'll solve for A. Okay, so if I want to solve for C, I'm going to use opposite and hypotenuse, so that's sine. So sine of 11.5 equals 3.5 over C. Okay, so this is my setup. And again, I would write a proportion, just put it over 1, and I would cross multiply. So I would multiply these, okay? So if I have to write it again, this is what I have. Sine of 11.5 times C equals 3.5 times 1, which is just 3.5. And then we're trying to isolate C, so then I would divide. So I would get C equals 3.5 divided by sine and 11.5. And once I get C by itself, then I just plug this in my calculator, okay? So let me clear 3 point, you know what? I'm going to use the fraction. Okay, so 3.5 over sine of 11.5. And by the way, notice it's still in degrees. I haven't changed it. Okay, so again, this is going to be an approximation, but I would say C is approximately 17.6. And if you're wondering why aren't I rounding to the nearest whole, because it is a side, not an angle. When it's an angle, I round to the nearest whole. And since this side has 1 decimal, I'm going to stick to 1 decimal as well. So I usually try to coincide. So this is going to be approximately 17.6 feet. Okay. All right. Now let's solve for angle A. Or not angle, I'm sorry, side A. So now I have... I'm going to go ahead and just stick to opposite and adjacent. Okay, so this would be opposite and adjacent would be tangent. So tangent of 11.5. Now you can use whatever you want at this point, because you can either use opposite and adjacent or adjacent and hypotenuse, as long as you use this one. Okay, so that's opposite 3.5 over adjacent. Okay, now you remember you're going to cross multiply, so eventually some of you will know the trick. So by now you realize I can switch these two. So I'm going to end up with A equals 3.5 over tangent 11.5. Okay. All right, so now let's use the calculator. So let me clear that. Again, I'm going to go ahead and use the fraction feature, and I'm going to write 3.5 over tangent of 11.5. Okay, and for A, I should get approximately 17.2 feet. Okay, so A is approximately 17.2 feet. All right, awesome, guys. All right, so I basically showed you all the different examples. So now you have enough to start on some practice and then your homework, okay? All right, guys, good luck. And if you need help, come see me.